Oh, okay. Good afternoon. Um, this is Dr. Osman Al Hassan, your only and only applied electricity lecturer. So I'm going to be solving um, quiz one that we did about two to 3 months ago, right? So it's been a long time. So in order to help you better prepare for the final exam, which is going to be taking place on 6th May, so I'm going to be solving quiz 1. So I have quiz 1. I'll be solving all the 3 questions. So we have question 1, 2, and then 3. Now, I've also solved other quizzes that I've done for mathematical students, computer students, meaning computer group A. I've solved their quiz 1, and then I've also done the solution for information system, right? Information system, IS students. I've uploaded all these solutions on my YouTube channel, right? So I will be uploading this content on the YouTube. So now let's get started. So we have first question. We have question 1. I have question 1 here. Question 1. A battery supplies a current of 4 amps and produces 72 kilojoules of energy for 3 minutes. What is the voltage of the battery? That's question A. And then B, 5 times 10 to the power 22 electrons are being transferred for 5 minutes. Find the amount of current flow in this period. So this is for question 1. You can see that it talks about voltage, energy, and then electrons, and then the time period, right? Now question 2 here, you are to calculate the current in figure 1. So we have figure 1 here, figure 1, and then we have question 3. You have to find the power dissipated by the 10 ohms resistor. So when it comes to question 2, I'm going to be solving it using branch current method, and then question 3 I'll be using mesh analysis method, right? So let's start with question 1 here. I have question 1. This is question 1A, right? Question 1A. We have a battery supplies a current of 4 amps. So I have current to be 4 amps. And then the energy is 72 kilojoules, right? So kilojoules, that is going to be 72 times 10 to the power 3 joules. So which is going to equal 72,000 joules of energy. And the time t here is going to be equals to 3 minutes, which is, so we change this into seconds. So 3 times 60 seconds. So I'm going to get 180 seconds. Now, when it comes to energy and then time, we know that power, right, is the rate of doing work. So, and then work done, which is a form of energy. So I can write power to be equal to energy over time. So we label this as equation 1. At the same time, we know power to be equal to what? current times voltage, right? So I'll label this as equation 2. So with this, you can see question, we are interested in the voltage, so I can equate equation 1 and 2 because we have power in both cases. So I can write E energy over time will be equals to 1 current times voltage. So this implies that voltage here, which we are interested in, to be equals to energy over current times what? Time. So voltage supply here is going to be equals to energy, which is 72,000 over current 4 times time, which is 180. So we have this will cancel, so we get here 7,200 over 4 times 18, that will be 72. That means the voltage is going to be equals to 100 volts. So the first question 1a, we've gotten the voltage to be 100 volts. Now let's go for question 1b. So I have question 1b, so let me write b here. Okay, so I have b. Here we have what? 5 times 10 to the power of 22 electrons are being transferred for 5 minutes. So we can hear the number of electrons here. I have 5 times 10 to the power of 22 electrons, right? And here the time, right? T, which is what? 5 minutes. And we change this again to seconds, so that will be 5 times 60 seconds. So time will be equals to 300 seconds. Now we have to find the amount of current flow in this time period. So we know current is the flow of charges. So I mean the flow of charges within a specific amount of time or within a time period. So I can write current to be equals to charge over what? Time. So we can see that we know current is time is given to be 300 seconds, but we are interested in now the charge. And to find the charge, we can, if we were to look at the end of the question 1b, you can see that we have 1 electron is going to give us 1.60 times 10 to the power minus 19 coulomb of charge, which is the magnitude of what? The charge, right? So now if 1 electron is going to give us 1.60 times 10 to the power minus 19 coulomb of charge, what of if we are having 5 times 10 to the power 22 electrons? How many magnitude of charge is going to be transferred? So here we can calculate the magnitude of charge by saying that 1 electron, or if 1 electron is equals to 1.60 times 10 to the power 22. Write this very well. Electrons. Sorry. Times 10 to the power minus 19 coulomb of charge. Okay. Now, what of if I'm having 5 times 10 to the power 22 electrons? What is going to be the charge, right? Magnitude of charge. So with this we cross multiply. Charge here is going to be equals to 1.60 times 10 to the power minus 19 times 5 times 10 to the power 22. So this is going to give me, so I'm going to get, so you multiply 1.60 by 5, so that's supposed to give you 8.01 times 10 to the power minus 19 plus 22, get 3 coulomb of charge, so which is going to be the same as 8010 coulomb. So that is my charge. Now I can find current, which is going to be the charge, which is 8010 coulombs over the time, which is, you can see T here is 300. So when you divide this, you are going to get 26.7 amps. So we get this to be the current. So that is for question 1B. Let's go to question 2. So I have my question 2. So we have question 2 here. I have question 2. Question 2 here, we have to find the current in figure 1, right? And with this question, I'm going to be using branch current method. So this is going to be the method I'll be using for this, for question 2. Now, to solve for this, that means that we have to assign current to each branch. So you can see that figure 1, we have 1, 2, 3 branches. So 1, 2, 3 branches. So I'm going to assign current to each branch. So if you assign current here, maybe I'll only for first branch I'll indicate to be I1, second one I'm label it to I2, then the third one we have here to be I3, right? I3. Here the voltage is 30 volts, okay, 30 volts. Now once I've assigned the current, now I'm going to indicate the polarities, right? The polarities on the resistors. We tend to indicate the polarities relative to the flow of current, right? Relative to the flow of current. So if I have, let's say for I1, right? So you can see I1. Okay, let's go to start with I2. See the current that is going through the 4 ohms resistor is I2, right? So when it comes to the second right is again I2. So that's the current. So I2 is going through 5 ohms resistor, and then the 6 ohms resistor we have I3. So in indicating the polarities for the 4 ohms resistor, I'm going to have plus and negative, because the current is entering from the positive here, leaves at negative. Now for the 5 ohms, again the polarity plus minus. So I have my I2 here, then I can have my I3 here as well. Here again the current is entering here positive and we have negative. You can see here this current will sum up, then I'm going to get here to be I1. So I1 is entering 2 ohms resistor here, so the polarity here will plus minus. So I've indicated the polarities, right? Now I'm simply going to apply Kirchhoff voltage law to the loops, right? I'm going to meaning to, let's say, loop 1. So I'm going to indicate my loop 1 to be the first loop here, which is this one here. So I have my loop 1, and my loop 1 is going to be for the second loop here. So that's my loop 2. So I have loop 1 and loop 2. So I'll be applying Kirchhoff's voltage law to each of these loops. So starting with loop 1. So when you come to loop 1, can see that in applying Kirchhoff voltage law, right, we have here to be 30 volts. Okay, here is 30 volts. So you can see here, because of the polarity here, I'm going to have negative, positive here. Then that is going to be a rise, right? Moving from negative to positive is going to be a rise, and then from positive to negative will be a drop. So if you see loop 1 here, I have 4 voltages, right? Meaning the 30 volts here, meaning the voltage across the 4 ohms, voltage across 5 ohms, and then the voltage across 2 ohms resistor. So I can write this 30 here, which is a rise. When it comes to here, the voltage across the 4 ohms resistor is going to be a drop, because I have plus negative. So I have 4I2, the current is I2. Again, for the what? The 5 ohm resistor is also going to be 1 minus, is going to be a drop, so I get 5I2. Then I come here, which is the 2 ohm resistor, is going, the voltage there will be what? A drop, so I have minus 2I1 equals to 0. So if I'm going to simplify this and label this as what? Equation 1. So if we were to simplify this, you realize that we get 2I1 plus 9I2 will be equals to what? 30. So we have here to be equation 1. Okay. So this is for equation 1. Now let's get the second equation by applying Kirchhoff voltage to loop 2. Now I have my loop 2 here, right? Now when it comes to loop 2, so we are going to move in clockwise, right? The first one we are moving clockwise, this one too we are moving clockwise direction. So with this movement, let's say we are starting from what? The 5 ohms resistor here. So mean the voltage across it. You can see now that I'm moving clockwise, right? And now moving from negative to positive. So meaning the voltage across the 5 ohm will be what? A rise. So that will be positive. So I have 5I2 here. Again, that will be what? Moving clockwise here, right? So now I'm moving from minus to positive here. So that will be what? A rise. So I have 4I2. Then when it comes to the second branch here, the third branch, you can see here is what? Clockwise. So I mean that will plus to negative, that will be a drop. So 6I3. Then we come back to what? The 5 ohms. So that will be a complete loop. So I have equals to 0. So this will be for the second equation. So we simplify this. So I have here to be 9I2 minus 6I3 equals to 0. Then equation 2. Now let's get the third equation, and we need a third equation in order to solve for the variables, right? Meaning because we are having here 3 variables, I1, I2, I3. So that means that in order to solve for each of these variables, we also need to have 3 equations, right? So 3 equations, 3 variables, or 3 variables, 3 equations, right? So I have here equation 3, and to get equation 3, I'll be applying Kirchhoff current law to a node, right? So let's say we have node A, and I'm going to label my node A here to be here. Okay, so meaning at node A here, when it comes to Kirchhoff's current law, we know that at a node, the sum of current entering the node should be equal to the sum of current leaving the node. So if I have here at node A here, you can see I1 is entering and I2 and I3 are leaving. So I can write here to be I1 is equal to I2 plus I3, meaning this is equation 3. So I've gotten my equation 3. Now it's just about solving, right? I have 3 equations, 3 values. So even once we've reached here, you can use your calculator to solve for the I1 and I2 straightforward, right? Especially during the final exams, whereby all the questions are just going to be multiple choice. So in that case, you don't need to show work. So you can just use your calculator and then you get this straightforward. But I'm going to solve this, right, without the calculator. So in solving equation 1, 2, and 3, so first starting, I can see that when it comes to equation 1, I have I1 and I2. Equation 2, I2, I3. Equation 1, I have I1, I2, I3. So I'm going to simplify, I'm going to make I3 the subject in equation 3 and replace it in equation 2. So with this, I have equation I3 to be equals to I1 minus I2. Let's say that gives me equation 4. Now put equation 4 into equation 2. So that gives me this. So inputting this into this, that means I'm going to have 9 I2 minus 6 into brackets I1 minus I2 equals to 0. So 9 I2 minus 6 I1. Here we want plus 6 I2 equals to 0. So we simplify this and we label as equation 5. So I have here to be minus 6 I2, 9 plus 6, that is 15 I2 equals to 0. Say equation 5. I have my equation 5 now. Now I'm going to write equation 1 below equation 5. So I have here to be equation 1 to be 2I1 plus 9I2 equals to 300. It equals to 30 rather. Equals to 30. So I'll label this as my equation 1. You can see that I can solve for what? I1 and I2 by using either substitution or elimination method. So I'm going to be using substitution method. Okay, I think it will be easier to use elimination method. So let me go for elimination method. So in using elimination method, I'm going to multiply equation 5 here, we multiply by 3. Equation 1 here, right, we multiply by 5, right, so that we can cancel the I2, because 3 by 50 will give us 45. 5 by 9 also 45. So I'm going to have this by 3 meaning minus 18. Right. Alright, yes, I2. I think there's a mistake here. Here we want I1 rather. Okay. So now we want minus. So here we are subtracting. So I have my minus here. So minus 6I1 minus. No, we are multiplying first. So meaning 3 times what? Minus 6. So minus 18I1. Now plus 45 I2 equals to 0. 5 times this, equation 1. So I have 10I1 plus 45 I2 equals to 1. 5 times 30, that will be 150. So let's label this as equation 6, right? Equation 7. So I have these equations here. Now I'm going to simplify so that we are subtracting. So I have minus here. I have my minus here. So this minus 18 minus 10. So here minus 28 I1. 45 minus 45, you get what? 0. So here we have what? 0 minus 150 minus 150 here. Okay. So you can see here I1 will be equals to 150 over 28. 150 divided by 28. So which is going to be equals to 5.357, right? Amps. We get this answer. That is for I1. Now let's see how we can find, let's say you can try and get, let's for example I2, right? You can go to equation 1, make I2 the subject because we know I1 now, and in doing so I2 just simply going to be equals to 30 minus, is it 2I1, right? Minus 2I1 over 9. So I have here to be equals to 30 minus 2 times 5.357 divided by 9. So if we do this, we have here times 2 times minus 1 plus 30 divided by 9. So that will give me I2 is going to be equals to 2.142, or you can even round it off to be 2.143. Okay. This is I2. Now you know I3 is I1 minus what? I2. So I have 5.357 minus 2.143. So I have here to be 5.357 minus 2.143. 5.357 minus 2.143. That is going to be 3.214 amps. So we have this. So I can have my forgotten I3, I2, I1. So we've calculated for the current for question 2. Now let's move to question 3, right? I have my question 3 here. Question 3, you have to find the power dissipated by the 10 ohms resistor with a current supply of 6 amps in figure 2. So what that means that the current supply here, 6 amps, is referring to this current here, right? Current that we have here. So with this, we have to find the power dissipated. Again, you can just simply write the power dissipated to be equals to, meaning by 10 ohms, so meaning 10 ohms here will be equals to the current that is passing through the 10 ohms, which is this one here, right? current that is passing. Maybe you label as 10 ohms current passing through this times what? Its resistance, which is 10 ohms. So current here we square. So this is the formula. So it means that for me to get this power, the power dissipated by 10 ohms resistor, I have to get the current which is passing through the 10 ohms resistor. So to find this current here, I'm going to be using mesh analysis method. I'm going to be using mesh analysis method here. Now, with the mesh analysis method, what we tend to do is that we tend to apply current to each loop, right? Which we refer to as loop current. So let's say for the first loop, we can have a loop, right? We have our first loop this way. Let's say loop 1 here. Then we have another loop, let's say loop 2 that I have here. So for the first loop here, you assign current to it. So I can assign, let's say for loop 1 here, I'm going to have I1, right? And then for loop 2, I will label as what? I2, right? So I'm going to indicate the direction of the current. So loop 1 here direction, because I have a voltage source here which is minus positive, so I'm going to have here to be current flow to be going this way, let's say clockwise. So you can say that for loop 1 I have 3 ohms and 10 ohms within that loop. So meaning this part here that I have, let me erase this for the time being. Right, so we are just having, this is our loop 2, right? So I now have what here? I have my I1 here, loop current I1 going to 10 ohms. Now you can see that the same is going to apply to what? For the second loop. You can see for second loop again, because here you can see the direction of the current, right? It's going there. But at this time, again, I'm going to make sure that here, right? Here I'm going to indicate the direction of what? My current, which is I here, to be going this way, right? It's moving clockwise. So that when we come here, we know here again, moving clockwise. So here I'll have also I2 here. So when you can now, after this, I can indicate the polarities relative to the direction of the current. So meaning for 3 ohms resistor, you can see I1 is entering. So I can indicate the polarities. So let me go back. So when you come to this part here, I can indicate the polarities here to be plus minus on the 3 ohms resistor. And then when you come to what? The 10 ohms, we have also plus minus here. That is relative to the I1, right? Then when you come to I2, you can see that for 5 ohms, because of direction, I have plus minus here. Then it comes the whole way. Now this time I'm having here to be 1. Again, here plus minus. So I've indicated the polarities. Now let me write the equation, right? So we are using mesh analysis. So we apply Kirchhoff voltage law to loop 1. So for loop 1 here, like I just indicated, I'm going to have, we are moving clockwise, so I'm going to have here to be, again, we are moving clockwise, meaning plus to minus to positive is going to give us 20, meaning rise in what voltage. And here you can see with the what 3 ohms, the polarity you have plus negative, so which is drop. So that means I'm taking the resistance by the current which is passing through, which is I1. Then we are moving, you can see now I1 is also going 10 ohms, so which is also be a drop. So say drop, so I'm going to get here to be, we get here to be 5 I1 as well. Then we come the whole way to what, the negative terminal of the 20 volt. So I can write this equals to 0. But bear in mind that when we reach here, right? Okay, let me, especially when it comes to this part, let me go back a bit. Especially here, see 5 amps is not here, it's not supposed to be 10 rather. You see we have I1 which is moving to 10, we are going this way, so rather 10 ohms. And then at the same time you can see that I2 is also passing through, right, the 10 ohms. So here we are going to take the dominant loop because we are in loop 1, so that loop 1 is the dominant loop. So I'm going to take I1 minus I2 here, right? Then we get 0. So we get this as the equation. Now with this is the equation that we've gotten for this part. Now I can label this as equation 1, or even before that we can simplify, right? We can simplify this equation. Even if you don't want to simplify, we can leave it this. Let's say I will just leave it like this, then I'll leave it at equation 1. Now we go to apply Kirchhoff voltage law to loop 2, right? So I have my loop 2 here. Now with loop 2, you can see that I'm moving what? Clockwise, right? And we move the whole way to this. So I can have here to be the voltage I have here. I'm starting from the 5 ohms resistor. So I have here clockwise. So moving from positive to negative. So I'm going to have minus 5i2, right? 5i2. Then I come back to my descent, right? Which is also going to be drop. So I have minus 10, which is I2, minus I1, which is going to be 0, right? But so with this, we can even see that we can avoid all this calculation here by just looking well, right? If you see here, for example, the current which is in loop 1 here, you can see that we have 6 amps there, right? So based on this, right, I can write, or I can indicate that I2 here, right, based on the direction, you can see that it's moving opposite to that of what? 6. So I can even just go ahead here and say I2 based on the diagram here. I2 is going to be equals to minus 6 amps. Okay. Because that's the only current which is what is in that loop, like especially this part. So once I've done this, it simplifies everything. I can even pick any of this solution, replace the current I2, and then solve for what. So let's say this is equation 2, and solve for I1. So let's say we are taking equation 1. So I can just write 20 minus 3 I1 minus 10, which is I1, minus, here you can see this is what, I2, which is now minus 6. So which means I have minus 6 here, goes to 0. So I have my 20, 3i, here what, minus 10i, here we positive, right? So positive 6, that will be minus 60, right? Goes to 0. So when you simplify for the current, you are going to get, right, you end up getting, okay, let me see, 20 here, 20 minus this, you get minus 40. So if you take minus 40 here, minus, you get minus 13i1 equals to 0. So you get I1 to equals to 40 over 13 minus 13 rather, right? So this will give us minus 3.077 amps for I1. So I've gotten I1, and then once I've gotten I1, remember we are interested in the current that is passing through a 10 ohms resistor. So we just come here, we indicate a node, which is node A here, and then at this node, right, once we can even indicate now the real current, right, which is, because here I have for this branch, I have only I1, mesh current I1, so I'll just go into label as what, I1 here. Then here we can indicate here now I2, real current I2, and can now indicate here to be what, I3, for example, right, I3. So now, because I3, you can see I3 is the current which is passing through the 10 ohms. So if we were to apply Kirchhoff current law at node A, you can see that we can write I1 to be equals to I2 plus I3, right? And then based on this, I can just make, I'm interested in I3, so I3, which is I1 minus I2, will be equals to I1, which is minus 3.7 minus 3.077, right, minus, right, minus I2, and you can see I2 again, this real current I2 here is going to be equals to minus 6 amps, right? It's going to be equals to what, the mesh current I2. So when you do this, you have minus, bring minus 6 here. So I3 here is going to be equals to minus 3.077 plus 6, and that gives me 2.923 amps. So we get this current. So we have here, we have this current here, which is I3. Now I'm going to go in, and this I3, which is the current, that's the current that is passing through. That's the current which is passing through the 10 ohms resistor. So I can write current which is passing through the 10 ohms equals what? I3, which is 2.923 amps. Now power, which is now just going to be equals to the current, which is 10 ohms square. It is now going to be 2.923 square times what? 10. That is just going to be 85.439 watts. So we've gotten the power to be 85.439 watts. So this is the solution for quiz 1.